Hello everybody, welcome back to another video. I'm hoping you guys are all having a fantastic day. So in today's video, as you can tell by the title, we will be talking about why I believe we are heading into a very cold and very snowy winter. Now, you may be like, okay, there's no way you have this much confidence this far out. And to an extent, you're right. This video is very speculative. It is mainly for the fun of it. It's not meant to scare anyone out about this upcoming, doom and gloom of winter. No, I am a weather enthusiast. I like making these speculative guesses about the winter, but as you will see in just a bit, they are not based off nothing. I will present to you a set of data, a set of research that I have found, and based off of that, I think it is reasonable to assume that we are heading for a cold and snowy winter. And this isn't based off nothing. This is based off a historical hidden pattern that I have found, and I am very, very excited to share with you. So let's jump right into it. So to start off, I want to address a few things that we will have to know in order to make this video make sense to you guys. So I made a video not long ago, a few days ago, really in-depth explaining what the ENSO is, the ENSO, the El Nino, La Nina neutral, and what that all means. So if you want a deeper understanding, I will include a little tab. It should show up in the upper right hand corner right around now, and you can click on that to get a greater understanding of the dynamics. I will briefly go over them right now. So basically, the ENSO is a region of the equatorial Pacific right in here. I'll circle it for you, and whether or not this is cooler, warmer, or neutral, it depends whether or not there's an El Nino, La Nina, or a neutral. And in this case scenario, you can see that it's pretty mixed, and that's why right now we have a neutral. There are some warm colors, some cool colors. And this is important because this area of the ocean, and depending on whether the waters are warm or cold, have a massive, massive impact on the North American winter. And these periods of warmer or cooler water temperatures are recorded into history all the way dating back to 1950 by NOAA, and you can see that here is the last 12 years of them. So a little brief history, and you can see there are different periods of warm, cool, neutral, and if you notice that 2024 into 2025, so last year we had a neutral, right? Notice that we came really close to a La Nina. We actually technically did cross into the territory, but it did not last long enough for it to be classified a La Nina, and we went back into a neutral state. And here is the ENSO forecast, and essentially what you have to know from this bar chart is that the chances of a neutral, right now, you can see they are pretty much sky high because that's what we currently are in, dwindle, but stay to the point of where a La Nina versus a neutral are just about as likely, and then the neutral comes right back into play later part of winter. So, essentially, as of this point, it is reasonable to assume that we are more likely to see a neutral as opposed to a La Nina. That can obviously change as we go further into time into the fall and winter, so I'll be definitely keeping you guys updated on what the chances are for a neutral La Nina or potentially even an El Nino. But at this point, the El Nino chances look very slim. Here is another model or another graphic which shows us the model prediction of the ENSO, the ENSO. And notice that these models are pretty much stuck right around the middle, and especially if you narrow in on these few thicker averages, these few thicker, I guess, lines, these are the averages, the little maroon and the green, and that basically shows where these models more or less average into one forecast, and you can see it keeps us at that neutral, almost La Nina, but more or less that neutral. This is another group of models that I like to look at, and it is kind of similar to the hurricane spaghetti models that you see during hurricane forecasts. And notice that this one has a lot more averages, but thankfully the Climate Prediction Center and NOAA that do these slideshows, what they did in order to make this easier to read, they put a little dashed black line in the middle showing the average. Now, this set of models, as compared to the other one, shows that little black dashed line going into the La Nina territory, which is technically half a degree below, and half a degree above would be El Nino. So this one shows a potential La Nina developing into November, October maybe, but then even by December, January, February, it also suggests that we are looking at more of a neutral pattern. So essentially, by showing you these slides, I wanted to establish that we are right now favoring a neutral ENSO, but it isn't impossible for a La Nina to develop. Now, this is where the really interesting and cool part comes in, and this is where I found something very interesting, and I want to share it with you. So what we have right now is very similar to the previous graphic I showed you a few slides ago, where we had those different years. Here are the years 2010, 2011, and the different 3-month season averages. So December, January, February, March, and it goes all the way through the end of the year. And notice this shows us the first, I would say the last 15 years. And what we have here is the different, as again as in the previous one, the different La Nina, El Ninos, and you can see some of them lasted for a while. Like in 2020 to 2023, we had quite a bit of a La Nina for a stretch of almost 3 years, and with a potential neutral upcoming this winter, right? What I've kind of figured, which it should be pretty easy here to figure this one out, we would have a back-to-back neutral winter, two back-to-back neutral winters. So the first one we had was last year, 2024, as you can see, into 2025 through the fall and the winter months. There was a brief period where it went into the La Nina territory, but it was still technically a neutral because in order for it to be a official La Nina episode, it has to last for a period of at least 5 of these 3-month average seasons. And with a neutral potentially predicted, again, we would have, again, 2 consecutive back-to-back neutral ENSOs. So I was thinking to myself, well, if I want to do a little bit of analog, find similar winters to this year, I have to start off by looking at previous times we had back-to-back neutrals. And let me tell you that this goes back to 1950, and it's only happened a few times. So on this graphic, the only other time this has happened was in 2013, or 2012, 2013 winter. Notice it was a neutral, also very similar, almost was a La Nina, but not quite. And then it stayed neutral, and into 2013, 2014, it did the same thing. So the back-to-back winters of a neutral ENSO. While I was doing this data backlogging, I was surprised to find out that there was only such few instances.19 than potentially this year, 2013, 2014, as I just showed you. The next one that we have to go all the way back to is 1992 was the first neutral winter, and then 1993 into 1994. So basically a 20-year gap between 2 consecutive neutral ENSOs. Then after that, we had almost another, it wasn't 20 years, but 15 years, where we had to go back to 1980. We had a neutral into 1981. And then 1981 into 1982. So there was a few more that we had that were, I think, one in 67, 68, and then 60 to 61. Other than that, none. So this has only happened 5 times in over the last 70, 80 years. So it's not often. And based off that, I was like, okay, so technically, if last year, 2024, 2025, was a neutral ENSO, that was the equivalent of, say, 1980 to 1981. And then this upcoming winter would be the equivalent of 1981 to 1982, the second neutral. So in the 1993 analog, it would be not 1992 into 1993, but the second neutral ENSO, 1993 into 1994. So essentially, I compiled all the winters of the second consecutive neutral ENSO, and I found something really interesting. And this is what I found. So right here we have a compilation of the different years, basically a composite anomaly, as you can see right here, it says at the top. And I combined the different years that had that back-to-back neutral ENSO winter in front of it, so the second neutral ENSO winter. So 1994, 1993 into 1994, 2013 to 2014, 1981 into 1982, and 1967 into 1968, and then another one, 1960 into 1961. So those are all the years. That's all we've had since 1950. It's really not that much. And then potentially the next one would be this upcoming year. And I compiled them. I wanted to see what the winters were like. And we had a overwhelming cold anomaly during December and February of those years for almost all of those winters. I will individually show you what each winter looked like month by month, but I also want to quickly go month by month of the anomaly. So notice that all these winters had a pretty cold December, but the really coldest month was January of all these years. That they almost always had a inline unison, really strong cold footprint during January that extended almost off the chart in terms of this graph, in terms of how cold it got. February was a little less cold, but still very, very cold. And so those are the 3 months of the winter. And as you could see, they were astoundingly cold across much of the United States. So now let's take it month by month. Okay, so let's start off in 1993. This was the December of 1993. You could see it wasn't necessarily barbarically cold, though there was a very cold footprint just to the north, so it was looming and ready. Actually pretty warm across the western Rockies and into portions of southwestern Canada, but overall chilly across the eastern and northern and southern United States. Now, this all changed as you got into January of 1994. As you can see, the cold footprint is just astounding. We are, quite frankly, off the charts we would have to extend this key probably up to -10 degrees. The cold footprint was extraordinary during January of 1994. And then February, also very, very cold. Let's move on to the next year, 2013 to 2014. This was December of 2013. You could see cold again. So colder than 1993 December, but still in line with the fact that it was cold. The southeast getting a little bit of activity there, that is, including some warmth. January of 2014. Also, very, very cold. Notice we had quite a bit of warmth across the west. So this pattern doesn't necessarily mean we will get a lot of snow or precipitation or, cold across the west. But it's almost very, very, very consistent anywhere east of the Mississippi that there is a lot of cold and a lot of it to a very extended period of time, not just 1 month during the winters. Okay, so let's continue going. We are now at January 2014. Let me go forward into February of 2014. Now you can see there's a lot more cold air across, say, southwestern Canada, and that includes some of the Montana, North Dakota, so some of those areas that were a little warmer early on in the year. Regardless, you could see that it is very, very cold. And the structure of the cold changes a bit. At first it's a little bit further east, further west, but essentially extremely, extremely cold. Let's move on to the next winter of the analog. December of 1981. So this was another year, and you could see December, cold. Now, it's kind of similar with all these years that December is not the coldest one. It's usually January or February. And you can see that it is definitely warmer across the south, southwest, but colder across Canada, and anywhere again east of the Mississippi. And also very distinguishable with these winters is the fact how deep this cold got. It got all the way to the Gulf of Mexico, and at a pretty incredible anomaly, 5-6 degrees for the month. That is very, very cold. And this is also, may I add, in Celsius, so these anomalies are even greater in Fahrenheit. January of 1982, I mean, this was a year I did some research on it where records were being broken across much of the Midwest, and apparently there also were areas that didn't have that much snow on the ground, so in some areas the cities broke records to how deep the frost went. I think in Chicago it was measured at 5 feet of basically soil being frozen, which is crazy. Notice in 1982, the cold swept all the way into pretty much the whole United States. Just a few pockets of warmth across the south. So not all the years are like that. Again, the highest confidence of the cold, based on these winters I'm showing you, is east of the Mississippi. But as you can tell, there are cold footprints that extend all over this country. February of 1982, you can see also cold, not as barbarically cold as, say, January, but cold nonetheless. All right, let's keep going into another year. This is December of 1967. You can see not every single winter is the same. While December was still overall colder than warmer for the country, it was flipped a bit. We saw more of the cold across the west, the Dakotas, and warmth across the southeast. However, this quickly changed as we got into January 1968. The cold pretty much extended just around everywhere, and there was a pocket of normal-ish conditions across the central United States, central western, but predominantly cold. And then February was really where the east got the brunt of it, and we had, again, very strong cold footprint anomalies and warmth across the west. Overall, another cold winter. December 1960, we saw predominantly cold across much of the United States, excluding portions of the southwestern Canada and northwestern United States. As you went into January, again, the cold continued into much of the southern United States, eastern United States, and the warmth across the west was more prevalent. Now, this is the only outlying month out of all these years. So you can see February of 1961 was, in fact, a little warmer. But overall, the winter on average was still cooler because this was just 1 month and a shorter month, while the December and January were still cold. I have one more thing I'd like to show you, and that is the precipitation of all these winters. Now, I didn't go month to month as much into it, or I'm not going to give you the same explanation as I did for the temperatures because the precipitation was a lot more, it's a lot harder to predict, and also there wasn't as anything incredible about it. You may be looking at this and being like, oh, it seems to be drier across a lot of these areas, so why do you say snowy? Well, the interesting thing is that actually with a lot of winters that do see a lot of snow across the Midwest or Great Lakes or southern Canada, when you do have higher snowfall, it tends to be a below average winter because you could have 7 inches of snow in Chicago, but if it's cold, that snowfall to liquid ratio is going to be very high, and you may get a lot of snow, but it would be a lot wetter of a season overall if you had warmer rains, for example. And this doesn't take into account snow or rain, it just takes into account precipitation. So the fact that it actually shows below average here indicates, again, cold and also snowier, because this isn't as big of an anomaly in order for it to show no snow. So snow definitely occurred, and I mean, really the best way to check this is just look at the snowfall records of these cities during these years, and they were quite extraordinary. Notice also the northwest getting on some of that action. That's a pretty strong footprint, and the northeast. And this, in my opinion, this is to do with probably, again, more warm air sliding off the oceans, but an activity increase of nor'easters. So there probably would be a lot of areas that do get rain, but also snow with some of these storms. In some of these years, there were legendary winter storms. Some of them produced rain or snow depending on where they tracked, but consistently they almost all had big nor'easters. And also notice across the south, increased precipitation. If you have increased precipitation across the south with a little bit of cold air, that also usually indicates increased snowfall. So this is why I believe that this upcoming winter will be colder and snowier. And as we get further into the fall and early winter, I will be continuously making updates about this and showing you more cool information that I find about these winter years. So that's basically it for today's video. Hopefully you learned something new. Hopefully you guys are excited for winter. I'll catch you all in the next episode. See ya. Bye.